Alright, here we're going to be talking about how to find the 5 other trig functions. Provided they give you one of the functions. And first problem here, they give me sine equals 4/5. So what I would do is this. Draw a triangle. Doesn't really matter. I'm going to make this my angle. I just put this little dot, right triangle. And here's what I'm always going to do. This is Libby's on the label. You will like it on the table. A little jingle, label everything. Well, this would be side adjacent, this would be side opposite, and this would be the hypotenuse. And so what I do is I go to sine, and we know sine is opposite over hypotenuse. So therefore the opposite is 4 and the hypotenuse is 5. So I would use Pythagorean theorem to find the other side first off. And because I have a hypotenuse in the leg, I know I will have 5 squared with the 4 squared, they're minus. So 25 minus 16 equals 9, and when I square root 9, 3. So this side is 3, which makes it really easy now because when I come over here and do cosine, which will be adjacent over hypotenuse, the answer is just 3/5. Tangent, which is opposite over adjacent, will then be 4/3. Secant, which is hypotenuse over adjacent, means it will be 5/3. So I'm just looking up here, it's already labeled for me, I don't have to think about it. Cotangent is adjacent over opposite, so that makes this one 3/4. And cosecant is hypotenuse over opposite, so it makes it 5/4. Or you could have done the reciprocal of the sine. That was right there. That's how I would do like 16. 17 would be done in the same way. Except this time, I'm going to take this very same problem. I'm going to erase this little bit right here. Because I'm going to draw a triangle, label it. But secant is 9/5. Remember, secant is hypotenuse over adjacent. So what that means is this is 9 and this is 5. So I'll still use Pythagorean theorem. And this time, I make little numbers right here. We're going to have 9 squared with the 5 squared. And because I have hypotenuse in the leg, I will minus them. So that's 81 minus 25, which I don't have paper in front of me. So I'm going to say it's going to be a 6. And to borrow 56. I think the square root of 56 is the same as 4 times 14, which makes it 2 square roots of 14. Or you could go to your y equals in your calculator and do 56 divided by x squared. And look at your table, and the last place you have decimals is your correct answer. You don't have decimals, your correct answer, which would be at 2 and 14. Making this one 2 square roots of 14, which is going to create a little bit of some problems down here. So first off, let's do sine. Sine is opposite over hypotenuse, which means I'll have 2 square roots of 14 over 9. Tangent is opposite over adjacent, so that will be 2 square roots of 14 over 5. I can't write very neat. Cosine will be adjacent over hypotenuse. So that's going to be 5/9, which is basically this one flipped upside down. Reciprocal. Cotangent is the reciprocal of the tangent. Or if I come over here and still do it this way, adjacent over opposite means I will have 5 over 2 square roots of 14, but there's a problem. I can't have a square root in the denominator, so what I'm going to do is this. I'm going to rationalize it and multiply it by 14, square root of 14. I'm going to have 5 times the square root of 14 on top, because 14 will go into 5 evenly. And basically that's going to make this now then 2 times 14, which will make it 28. I think I took that away just to kind of see what I have to do. So it's 5 squared root of 14 over 28. And then cosecant is the hypotenuse over the opposite. I had to stop thinking about it myself a little bit. So that's going to be 9 over 2 square roots of 14, and I have the same problem I had on the last one. We're going to have to rationalize that. So it's going to move the square root of 14 up. And 2 times 14 once again will be 28. So those are my particular numbers right there. And I do want to kind of briefly, those would be the answers how you find that. But the biggest thing is to draw a triangle and label it.